So let's get some practice and hopefully a little bit of intuition for adding and subtracting two-dimensional vectors. So let's say that I have vector A, and let's say that its x component is, 3, and its y component is -1. And let's say we also have a vector B, and let's say that its x component is 2, and let's say its y component is 3. Now let's first think about what would A plus B equal. So what resulting vector would this be? A plus B is equal to what? And I encourage you to pause the video and think about what this would be. Well, the convention is if we're taking the sum of two vectors, we can just add up their x components to get our new x component, and add up their y components to get the new y component. So the x component of vector A plus vector B is going to be 3 plus 2. That's going to be the x component, which we know is 5. And the y component is going to be -1 plus 3. -1 plus 3. And so the resulting vector is going to have an x component of 5, and a y component of -1 plus 3 is equal to 2. All right, that was pretty straightforward. Now, instead of adding them, let's think about what would happen if we subtract them. So let's think about what vector A minus vector B would be. And I suspect that you might be able to guess, or at least think about what would happen if you subtract vector B instead of adding vector B. Well, as you might have guessed, instead of adding the corresponding components, we subtract it. So our x component is going to be the x component of A minus the x component of B, because it's vector A minus vector B. So our x component is going to be 3 minus 2, 3 minus 2, and our y component is going to be the y component of A, -1, minus the y component of B, so -3, and so the resulting vector is going to be the vector 3 minus 2, the x component is going to be 1, and then the y component -1 minus 3 is -4. Now what I just showed you, this is the convention for adding and subtracting two-dimensional vectors like vectors A and B. Let's think a little bit about how we can visually depict what is going on. So let's first visually depict adding vector A and vector B. So let me draw some axes. And so this could be, there's my y-axis. Let's see, the highest y value I get to is, the highest y value I get to is 3, and the lowest is -4. And then, so let me draw the x-axis someplace. Whoops, I didn't mean to do that. I did the zoom by accident. All right, so the x-axis, put it right over there. There's my x-axis. And let's see, the highest x value is 5, the lowest is 3. Actually, I could just focus on the right-hand side. So that's y, and then let me do x looking like that, x-axis. And now let's see, vector A is 3, -1. So 1, 2, 3, and -1. If we want to just visualize it in standard form, we could put its initial point at the origin and its terminal point at the point 3, -1. And so we could draw it like that. We could also shift it around as long as it has the same magnitude and direction. We could shift it around. So that right there is our vector A. Now vector B, 2, 3, we could have its initial point at the origin, and we could draw it like this. So the x-coordinate is 2, y-coordinate 1, 2, 3. So its terminal point could be there. So we could just draw it like this for vector B. But if we're going to add vector B to vector A, like we have right over there, what we want to do is shift vector B over so that its, I guess you could say, tail starts at A's head, or its initial point starts at A's terminal point. So let's do that. So if we start right over here, we're going to go 2 in the x direction. So we're going to go 2 more in the x direction, and we're going to go 3 in the y direction. So 1, 2, 3. So we're going to end up right over there. So notice, this is the same vector, vector b. I've just shifted it over. It has the same magnitude and same direction as what I had drawn before as that vector right over there. I have just shifted it down and to the right. And now when we do this, so this is vector A. I'm adding vector B. I put the initial point of vector B at the terminal point of vector A. I've shifted it over right over there. So now I can figure out the resulting vector A plus B, the resulting vector A plus B, by going from the initial point of A to the terminal point of B. So it's going to start here and then go over there. And notice, this vector, I'm going 5 in the x direction and 2 in the y direction. This is the vector 5, 2, right over there. That is vector A plus vector B. Now let's think about what happens when we do A minus B. Well, we could still have vector A just like we drew it, but now instead of putting vector B's tail or initial point at the terminal point of vector A, we would want to put negative B. So negative B would just have the same magnitude, but it would be in the opposite direction. So instead of going 2 to the right and 3 up, we would go 2 to the left and 3 down. So just 2 to the left and 1, 2, 3 down, and we would end up right about there. And so if you subtract A minus B, that's the same thing as A plus negative B. So negative B is going to look something like this. It's going to be the exact opposite direction. It's going to look like that. And so there, if you start at the initial point of A and get to the terminal point of the negative B now, this is all hand drawn, so it could be a little bit more precise. Notice, we get to the point 1, negative 4. 1, negative 4. So this vector right over here, let me do that in a different color. This brown, whoops, that's not what I wanted to do. This brown vector right over here, that is the vector A minus B. And then this white one, actually let me do this in another color as well. This magenta vector right here, that is A plus B. So hopefully that makes sense. And if given the components, if you're adding the vectors, add the corresponding components. If you're subtracting the vectors, well, if you're subtracting B from A, subtract B's corresponding components from the corresponding components of A.